All right, we are working on Chapter 8.5 Notes, Graphing Linear Inequalities. So the things we need to be able to do are determine if a point is a solution to a linear inequality of a graph or an inequality itself. We need to be able to graph the inequalities, to write inequalities from graphs, and write and graph an inequality from a word problem. So those are the things we're going to look at today. First of all, let's just look at this problem. We have Axel and Anita. They pay for and share a memory storage at a remote internet site. So their plan allows them to upload 250 terabytes, TB, or less of data each month. So they can upload 250 or less. Let X represent the number of terabytes that Axel uploads, and then Y is going to be the number of terabytes Anita uploads. So we have X and Y here. We have a table that has some questions for us because we want to know, if we look at this data for the month, determine if Axel and Anita stayed within the limits of their monthly plan. So that's what we're going to put here, a yes or a no. Did they stay within this 250 or less terabytes? So that's what we are going to look at first. So if Axel uses 50 terabytes and Anita uploads 120 terabytes, that gives us 170 terabytes. So is that within the plan? Yes, it is, because it's less than 250. So our answer is yes there. Next, we have 135 terabytes and 100 terabytes. That gives us 235 terabytes. Is that less than or equal to 250? Yes, it is. Next, we have 100 terabytes and 150 terabytes. So that gives us 250 terabytes. Does that fit within our plan? Yes, it does. Any higher and it wouldn't fit, but that one does fit. And lastly, we've got 162 terabytes and 128 terabytes. Does that fit? Well, that gives us 290 terabytes. Does that fit into our plan? No, it does not. They can only upload up to 250. So the answer to that is no, it does not fit into our plan. So the reason we are looking at these examples is we are looking at how there are a lot of different possible solutions for a linear inequality. So let's go ahead and write an inequality that models the restrictions of this plan. Our inequality is going to have our X and our Y. Now what does X stand for? X is how many terabytes Axel uploads, and Y is how many terabytes Anita uploads. So we know that the sum of those, we know that Axel's uploads plus Anita's uploads, they cannot exceed, or they have to be 250 or less. So does that mean that what we have here is going to be bigger than 250 or less than 250? Well, if they have to be 250 or less, we want X plus Y to be less than 250 or equal to. So we have X plus Y is less than or equal to 250. Now that we have our inequality, let's look at the next part of our problem. So it says the graph represents the possible values of the number of terabytes that Axel and Anita can upload. So that is what our graph is here. Let's just move that up. Now we can see it better. So an ordered pair X comma Y represents the number of terabytes that Axel and Anita upload. For example, if we go to the coordinate 100, that's about here, comma 75, 175 is about here on our graph. That tells us that Axel uploaded 100 terabytes of data and Anita uploaded 75 terabytes of data. So Axel is our X. We can go ahead and label that Axel's uploads and Anita's uploads. So what we want to know is, based on this graph, the shaded region of the graph, we want to see if each of these ordered pairs fall in there. So we are going to graph each of the ordered pairs and tell whether or not they make it into their plan, whether or not Axel and Anita stay within their plan. So if we go to the ordered pair, 200, 50, let's look at that. Now, these are scaled by tens, so 200 will be here, 50, and let's go ahead and place that on our graph. That is right here on the line. So yes, that one is a part of our shaded region. We want to know if it falls into their plan, and yes, it does. They stayed within their plan there. Now let's go to 150, that is here. Is that within their plan? No, it's not. You can see it's outside of the shaded region. Again, the shaded region is where their plan takes place. So anywhere in this shaded region is fair game for their plan. So now we need to look at 225.25. That is 225's here, and we go up to 25, so it looks like it falls right on our line here. So yes, that one is part of their plan as well. That one is on the boundary line. Go to 20 and then up to 120. Clearly that one is within the shaded region. So again, it's a yes, that falls in their plan. And lastly, we go to 120 and up to 200. So that is here. And again, that one's pretty clear that it is not in their plan. That's not in the shaded region. So the reason we are looking at this is kind of like up here. We're looking at how there are a lot of different solutions to these linear inequalities. And now we're going to talk about how to graph linear inequalities and the steps we take for those. So that was just to introduce us to linear inequalities. This graph, this example we just looked at, is an example of the graph of a linear inequalities in two variables. So that means we've got an x variable and a y variable. All the points in the shaded region are solutions to the inequality. So let's look at the next section. What is an inequality? What does it look like? There are 4 different ways that it could look, and that's just based on the 4 different inequality symbols we have. We could have ax plus by is less than c. We can have ax plus by is greater than c. And then we could have both of those with the equal to symbol underneath. So that would be ax plus by is less than or equal to c. And ax plus by is greater than or equal to c. So that is how we are going to write our linear inequalities. It'll look like one of these inequalities there. Now, what does it look like to have a solution or to have solutions of the linear inequality? What we said with this graph up here is that there are a lot of solutions. It's anything in this shaded region. So solutions of linear inequalities, a solution is going to be an ordered pair, x, y, so x comma y in the parentheses, that makes the inequality true. So any ordered pair that makes the inequality true. That would be anything in the shaded region of the graph. All right, let's talk about boundary lines. I mentioned the boundary line earlier, right here, where the boundary line separates the shaded region from the non-shaded region. So the boundary line is a line that separates the coordinate plane. So it separates the coordinate plane into 2 regions. Oops. It should say 2, into 2 regions. And they are called half planes. So it separates it into 2 regions called half planes. So up here we have these 2 regions, both of them called half planes. And with the half planes, we consider them open sometimes and closed sometimes. So they are going to be open when we have a dotted line. That's a dashed line there. So when we have a dotted line, they're going to be open. That's kind of like on a graph when we have an open circle, the point is not included. So in this case, when we have an open graph, when we have a dotted line, anything on that line is not included. And that will happen if we have greater than or less than. Not equal to. So that means when it's open, it does not include the line. That's when it's open. Now when it's closed, it's going to be a solid line. And I'm guessing you can guess that it is less than or equal to and greater than or equal to. That is what we have for closed. So for closed, it does include the line. So these are tools we will need to be able to graph, and here are the steps. The steps to graphing a linear inequality is we are going to start by graphing the equation of the line. And the best method to use is slope-intercept form. First we start by graphing the equation. Then we're going to determine if the line is solid, so that is if it has the equal to line, or if it is dotted, and that is if it does not have the equal to line. We graph the equation, we determine if it's solid or dotted, then we're going to pick a point. Pick a point on the graph that is not on the line, that's very important, and test it in the original inequality. We will shade the side that is true. So if we test it in the inequality and we find that it is true, let's say we tested this point and we found it was true, that would mean we would shade this entire area. Now just as a rule of thumb, the point 0, 0 is the easiest point to choose. So that's going to be my default point to choose, but we can't choose it if it is on the line. So now we are going to stop the video, and I have a few questions for you to answer, and then we'll pick back up on the back of the notes.